All right, so let's go ahead and talk about properties of real numbers. So this section we're going to talk about a few different properties that relate to reordering numbers, how you can add and multiply them. And most of these you don't have to know by name. They'll show up on the homework where they use this property to do something with an expression. On the exam, you don't have to know them by name, but you do have to know when to use these. So that's what these are going to be helpful for. So the first one here is called the commutative property. Now what the commutative property basically tells us is that for addition and multiplication, and note that these don't apply to division and subtraction, we can add or multiply in a different order and still get the same result. So for addition, this means if we have two numbers a plus b, this is the same thing as b plus a. And for multiplication, this means if we have a times b, this is the same thing as b times a. So think 3 times 5 is the same thing as 5 times 3. But if we had this for subtraction, let's say we have 3 minus 5 and 5 minus 3. 5 minus 3 is going to give us 2, but 3 minus 5, because this 5 is the larger number and it's negative, this gives us a negative 2. So this does not hold for subtraction. Our second property here is called the associative property. And this has to do with grouping. So again, this works for addition and multiplication, but not subtraction or division, sorry. So let's say we have a plus b grouped, so in parentheses, and then we add c. Remember that with order of operations, this group here is telling us that we have to add a and b first, and then add c to whatever we get from that sum. This is the same thing as if we were going to move around these parentheses and we had a plus parentheses b plus c. So with addition, doesn't matter which ones you add first. As long as this is all addition, there's no subtraction in there, this is going to hold. Same kind of thing for multiplication. We're just going to replace these addition signs with multiplication. So a times b in parentheses times c is the same thing as a times parentheses b times c. So we can multiply and add in different orders and still get the same results. So let's go ahead and look at some examples here. For these set of examples, we want to use the commutative property, and I'm just going to abbreviate that COMM, property, PROP, to complete the statement. And so these are just more to get you familiar with when you can use these properties and why they're helpful. You won't always have to explicitly use the commutative property or be told to use the commutative property. So this one here, we're given x plus 9 equals 9 plus blank. And so all we're doing here is realizing that commutative tells us we can switch these around. So we have 9 plus x. Number 2, if we have 5x equals x times blank, this is just telling us, again, we can switch these around and we get x times 5. Now let's just look at a couple of examples for the associative property. So we want to use the associative property, abbreviate this ASSOC prop, to complete the statement. So we're doing the same kind of thing. So number 1, we're given -5 plus parentheses 2 plus 8 equals parentheses blank plus 8. So this one here is realizing that we can take these parentheses because it's all addition and move them over and group the -5 and the 2. So in the parentheses here, we're going to have -5 plus 2. And now the second one here, we're given 10 times brackets, because we're going to have some parentheses in here for the negatives. -8 times parentheses -3 and bracket is equal to, and so for this whole answer here, we want to go ahead and use the associative property. And so there's only one other place we can move these brackets. These brackets have to move over to our first group here. So we're going to have brackets 10 times parentheses -8. And I'm just putting those parentheses around the -8 so we don't have multiplication right next to a minus sign or a negative sign. And the brackets times parentheses -3. So this entire thing was our answer for this one. All right, so that's just being able to identify what we can do using each of the properties. So commutative, think when you commute to work, you move, so we're moving the terms. Associative, the numbers, when we move around the parentheses, are associating with a different number. So that's another way you can remember that one. All right, this next set of examples, we want to figure out which property or properties are being used. So we want to know commutative, associative, or both. So number 1 here, we're given 2 times parentheses 4 times 6 equals parentheses 2 times 4 times 6. And so if you notice here, none of the actual terms changed their order. We have 2, 4, 6, 2, 4, 6. We only moved the parentheses. So think about what this one's going to be for a second. And if you wrote down associative, you're correct. All right, number 2, and one thing to note, just because you see parentheses doesn't mean it's associative. So this next one, we have 2 times 4 in parentheses times 6 equals, and then in parentheses, 4 times 2 times 6. So notice here we still have parentheses set up, but the parentheses aren't moving. What did move is these first terms here switched around. And so because the terms moved, this tells us that we have the commutative property. And then lastly here we have parentheses 2 plus 4 plus 6 equals 4 plus 2 plus 6 in parentheses. All right, so now with this one, take a look at what changed. So let's take a look at parentheses first. They were in the front here, and now the parentheses are at the end. But the order of these also changed. We had 2, 4, 6, and now we have 4, 2, 6. So we also flipped around the 2 and the 4, which means we have both commutative and associative. All right, so now let's go ahead and use these 2 properties. This is more of the type of questions you'll see on an exam or in real life when you want to use these when you're doing something in a science class or something else. But we're going to go ahead and find the sum or the product that we're given. Notice we're still not using subtraction or division because it doesn't apply to those operations. For this first one here, we're given 5 plus 18 plus 29 plus 31 plus 12. And so for something like this, especially in these classes where you don't have a calculator to just go ahead and add all these up for you, it's smart to go ahead and make pairs that make tens. So if we go ahead and look here, there's no other number that ends in a 5, so this one's not going to be helpful right now. But this 18, if we add a 2 or any number that ends in a 2 to this, we'll get a multiple of 10. So 18 plus 12, we get 10 and 10 plus 10 more from the 8 and the 2, so we get 30. And then we can do the same thing with the 29 and the 31. I'm going to try to squeeze these in here. 29 and 31, so 20 and 30 is 50, plus 10 more is 60. And so now, working with the only numbers we have left, we have 5, 60, and 30. And so 60 plus 30 is 90, plus 5 is going to give us 95. So being able to rearrange these is really helpful. The only thing to look out for is if you have subtraction or division in there. All right, this next one here, we have 5 times 37 times 20. And notice these parentheses aren't used to group. So we're not going to be moving around the parentheses. They're just used to show multiplication. And so for this one, I don't really want to have to multiply 5 times 37 first. But if you notice, 5 times 20 is pretty nice. That gives us 100. And so now all we have left is 100 times 37. And multiplying by 100 is really nice because all we need to do is take the 37 and add 2 zeros. So these properties here, all they really do is make it easier to multiply and add things together. All right, so this next property or set of properties here are called the identity properties. We'll go ahead and add a new page here. So the identity properties, again, not really something you have to know by name other than on the homework, but knowing when we can use these is going to be helpful. And we've already seen this one. So the identity properties basically keep the identity of the number. So a number that we're given is not going to change. And so for addition, the identity property tells us that if we have some number plus some number here is going to give us back the same number. So what number can we add to any number and still get the same result? We can add 0. And so the identity property for addition is some number plus 0 equals that same number. Or if you flip it around and have 0 plus a, you still get a back. So we're keeping the identity of the number that we started with. And it works the same for multiplication, except now we're trying to multiply by a number and keep the same identity. So if we have a times some number equals a, well, again, what do we have to multiply a by to keep a? The only thing we can multiply it by is 1. So the multiplication identity property tells us some number times 1 is still that same number, or 1 times that number is still the same number. So 1 times a equals a. And our next property here, the inverse properties. The inverse properties, this first one we've talked about a little bit. So if we have a plus the opposite of a, if we add together, let's say 3 and -3, we always get 0. Same thing if we flip those around, -a plus a equals 0. And we call these additive inverses. And so we saw that a couple of sections ago. And one thing I reminded you guys was that your book will call it additive inverses. Most of the time you'll just hear them called opposites. All right. One thing I want to note here is that even if you have fractions, so say 1/3, the additive inverse for 1/3 is -1/3. So this isn't reciprocals where we're flipping the fraction. This is just an additive inverse or an opposite, so we're just changing the sign. So that's for addition. Let me go ahead and actually add that in there so that you have it. For multiplication, this one tells us what we can multiply two things together and get 1. So this is again one we've seen before. This tells us if we have A times 1/A, so a number times its reciprocal, we get 1. So you can think of these A's as just canceling out. Same thing if we reverse the order because they're commutative. We have 1/A times A equals 1. And so these are what we call multiplicative inverses. So another kind of fancy name for these, but what we usually call them are reciprocals. And just a couple of examples of those. Let's say we have the number 1/5. The reciprocal to this one, if we flip this, we get 5/1, which is just 5. And notice how the sign stayed the same. So if we have the number -2/3, the multiplicative inverse is the same sign because we're not looking at the additive inverse. All we're going to do is flip it, so we get -3/2. All right, so this last property here is a very important one, and this one you do want to know by name because it's going to pop up time and time again when we start solving equations and simplifying expressions. This one's called the distributive property. So what the distributive property tells us is if we have some number, we'll call it A, times a group B plus C, and it doesn't have to be addition in here. It's either addition or subtraction. What we're going to do is distribute this A into both of these terms. And since this is A times B plus C, we're multiplying A by B and multiplying it by C. So we get A times B, or AB, plus, and that one's just going to depend on the sign because A and C, as far as we can see, are both positive. Then this is a plus, A times C. So this is a big one. I'm going to put stars around that one, highlight it, but we're going to use that one a lot. So let's go ahead and just take a look at why this property works. So let's say we have 2 times 3 plus 5. And we're going to go ahead and simplify this both ways. I'll put a question mark on top of the equal sign, so we don't know if they're actually equal yet, the way that we're going to simplify. The first way we can do it is just by using order of operations like we've done before. So simplify inside the parentheses. So we get 2 times 8, and 2 times 8 is 16. And now on the right side, normally we don't use the distributive property with just numbers because it's usually easier to go through and do it this first way. This way is going to need to be used when we have variables, which we'll see in a second. But let's go ahead and try distributing this. So we're going to have 2 times 3 plus 2 times 5. 2 times 3 is 6, plus 2 times 5 is 10. 6 plus 10 is 16. So we do get the same thing. Again, you don't have to use it with numbers. Normally we don't. Stick to this for variables, which is what we're going to see next. All right, so the last set of examples here for this section. For these ones, we want to distribute. And it might tell you to use the distributive property to simplify, same thing. So number one, we're given 2 times the quantity of p plus 5. So we're going to introduce some algebra here. So we want to go ahead and distribute this 2 into both of these. So we're going to have 2 times p, which we'll write as 2p, plus 2 times 5. And I'm just going to write this one out kind of the long way, doing it this time. The next one we'll kind of skip this middle step here and multiply straight away. We can't do anything with 2p. We don't know what p is, so we'll leave it as 2p. Plus 2 times 5 is 10. So 2p plus 10. And like we'll start talking about next time, we can't add these two together because they're not what we call like terms. All right, let's try another one. -4 times y plus 7. So now with this one, let's go ahead and distribute, and we're going to go straight to this last step here. So -4 times y is -4y. With variables, you just kind of put the number in the front as a coefficient. And then -4 times 7 gives us -28. And so now, one way you can write this, it's not the best way to write this, is plus -28. Having that plus negative there looks kind of ugly. So what we're going to do, anytime you're multiplying and you have something like this where -4 times 7 is -28, that's the same thing as just writing -4y minus 28. So remember, this is adding the opposite here. So get in the habit of just going straight to this last step. All right, let's try another one. -5 times 4x minus 3. So now one thing we're going to see here with this first one, when we distribute -5 into that 4x, -5 times 4x, we can multiply the numbers here. We just can't add any terms like we end up with at the end of the first two. -5 times 4 is -20, so we get -20x. X just kind of comes along for the ride. And -5 times -3, focus on the signs that are in front of them, gives us a positive, so plus 15. All right, number 4, -2/3 times 6x minus 3. This one looks a little uglier because we have a fraction. We're still just going to distribute that in. So I'll just do the multiplication kind of off to the side. So -2/3 times 6x, I'm just going to focus on the 6, and we'll write it as 6/1. And I'll go ahead and reduce at the end because these numbers aren't too bad. So negative times a positive is going to give us a negative. 2 times 6 is 12 over 3 times 1 is 3. And -12/3 is -4. So our first term here, just don't forget that x. We get -4x. And then -2/3 times -3, don't forget the negative, over 1. So now a negative times a negative is a positive, and this one I am going to go ahead and just cancel out those 3's. So we just get negative times a negative is a positive 2 over just a 1, so 2/1 is 2. And it's positive, so we have to put plus 2. All right, so normally the only thing that gets kind of ugly about these is the arithmetic you might have to do off to the side. But for the most part, it's just distributing and remembering your signs. That's the big thing here. These last ones are a little bit longer. So number 5, we're given 7 times 2y plus 7k minus 9m. So this works exactly the same with 3 terms instead of 2. We're going to distribute this 7 into all 3 of the terms. 7 times 2y is going to give us a 14y. 7 times 7k, 7 times 7 is 49, and it's positive, so plus 49k. And then 7 times negative 9 is negative 63. Bring the m along with it. All right, number 6. This one looks a little weird because there's not an actual number that we can see in front of the parentheses. We have negative parentheses 3k minus 5. And so this is one where you'll usually see some other terms in front of this minus sign or this negative sign here. But you just want to go ahead and think of this negative as a negative 1. So whenever you don't see a number, there's always a 1 there. So if I multiply both of these by negative 1, negative 1 times 3 is negative 3k. And negative 1 times negative 5 gives us a positive 5, so plus 5. And so all that negative really does, if you notice, it just changed the signs of each of these. And now one last one here, negative, and in parentheses, negative t minus 4u plus 5v. And so going based off of what we just talked about in this one up here with this negative, just changing the sign of these, go ahead and try changing the sign or distributing a negative 1 into all 3 of these terms. So I'll give you a second to do that. And then we'll go ahead and end this section here. So a negative 1 times negative t makes it a positive t. And same thing in front of that t, it's a negative 1t. We just don't usually write it. So negative 1 times negative 1 is 1, which we can technically put in front of the t there. We just prefer not to. Negative 1 times negative 4 is positive 4u. And negative 1 times 5 is negative 5v. So you should have t plus 4u minus 5v. All right, so that's it for 1.7. Next time we'll be getting into our last section for chapter 1, and we're going to start simplifying expressions, which is just going to kind of get us started on our algebra stuff.